What's this stuff we got down here under our feet? Well, clearly it's in a layer, but it's also pretty clearly a volcanic rock. So we've got ourselves a layered volcanic rock spread across the landscape here. What happens in a couple of thousand years' time, and this is exposed in some sort of a geological section, because after that the sea level has dropped back down again, and there's a nice big cliff face there with dune sands and everything underneath it, and then this thin layer of stuff all through the middle of it, and all sorts of other garbage over the top, growing grass and trees and whatever, and they're going to come in and see this beautiful stratigraphic sequence. Are they going to recognise it as part of the human cycle back in the 20th century? Yeah, that's moving from geology to archaeology. Remember our car park dilemma of was it sedimentary or was it volcanic back at the last stop? We've got the same damn stuff here again. But is it the same stuff? Is this a continuous layer from here back to there, and should we therefore treat it as a single strata right through this whole sequence? Well, the answer really is yes, because it goes out onto the road and down the Wakehurst Parkway and round Pittwater Road and back into the next car park. So in fact it is a single depositional layer over the whole of the metropolitan area, if you like to trace it out that far. But from place to place it differs. How is this one different from the last one? It's got a lot of little round quartz pebbles in it, right? Hawkesbury sandstone has little quartz pebble layers in it at the bottom of the channel fascies. This is the high energy load carried by the Hawkesbury sandstone river way back in the Triassic. Now you'll find it all over the hill slopes, you'll find it in the soils wherever there are Hawkesbury sandstones, but what I'm doing in all of this is showing you how a geologist goes about their business. That's exactly what we're doing. Now we've got over on the hill slope here, we've got masses of sandstone. You can see the odd boulder lying around, and then if you look up into the trees you'll see little bits of broken cliffy outcrop. This boulder here straight over behind us is obviously not in its original position, because it's tipped down on the side of the slope and is moving down slope ever so slowly and lodging itself at the edge of the car park. But above the dogs on the other side over there, the big bluffs are in fact horizontal, and they're cliff lines and they're in position. They haven't moved at all, so that's the source of the boulders from a little bit further upslope. And I've marked the bit of the Sydney Basin stratigraphy that we'll be looking at today with a bit of a pink blob. We're nearly at the base of the Hawkesbury sandstone at this point. So what's above us should be the Waitemata Group shales up there. Well, this time we're looking up there and it isn't there. How do I know that the Waitemata Group shales are above us? Because the crests of these ridges, and particularly over around through St Ives, get up into the shale and give you very different sorts of soils and different sorts of rather more gentle ridge-top landscapes. The soils were more attractive from an agricultural point of view, particularly for orcharding, and the ridges coming out of the CBD and across the harbour were also much more attractive from the point of view of good transport routes. So the shale country on the North Shore was the first area that was developed when the Europeans turned up and started spreading out their wings. The roads went along the ridges, the railways went along the ridges, the suburbs followed them, the orchards followed them, and then the whole lot got built out, and now of course we've got so much money we can build on horrible slopes like those over there anyway. We also know that above the Waitemata series there were other rocks that are not shown on that column. They've gone, they've completely eroded away. How far up there? Nearly a kilometre. So in the last 180 million years, a kilometre of rock has disappeared from the Sydney Basin. Where the hell did it go?
In the sea.
Into the sea. Where was the sea 180 million years ago?
300 kilometres that way.
Well, Australia was well and truly further south. The Tasman Sea didn't exist. Australia was still connected to Antarctica. And New Zealand, such as it was a whole series of little muddy sediments and bits of volcanics and stuff stuck on the east coast, more or less. So the Jurassic sediments from up there, plus a lot of the Triassic series sediments of the edge of the Sydney Basin, were dumped in the ocean in what is now New Zealand. So if you go to New Zealand and you look at the fossils that we'll see later on this afternoon over on Parramatta Headland, you'll find the same fossils in the same age rocks in New Zealand in fine grained sediments. So New Zealand has a lot of East Coast Australia geological links. because the Tasman Sea opened at about 100 million years ago and broke the two places apart, and we no longer have that sort of connection. Yeah, so it's amazing, isn't it? You go from a bit of basalt in the car park through that whole complex story that actually takes you back 200 million years and puts you in touch with New Zealand in a geological sense. Alright, if you rammed a hole down through here, you'd expect to go down through the rest of that column, down into the Permian sediments, and at the bottom of the Permian sediments you'd get right down into what we call basement, which is actually Devonian sediments, about 400 million years old. In the bottom of the Permian we have the coal measures. The coal measures outcrop at Lithgow, Newcastle and Wollongong, but they're also underneath us. In fact, we worked coal underneath Sydney Harbour from a coal mine at Balmain, and in the 1880s the geological department was very interested in doing more coal exploration, and they had half a dozen diamond drills that they let out on hire to various people to go and search for coal to see if they could find where it was shallowest and whether it was economic. And of course you'd come here to do that because this is the closest part you get to those deeper sections. So in 1885, here in Deep Creek, a private enterprise group spent £7,000 drilling, diamond drilling to the sequence to try to get down to the coal measures and find out what it was worthwhile. This is another drill, probably in fact the same drill that was done over at Cremorne a couple of years later. And it gives you a bit of an idea of the technology of the day. We're talking steam engine and we're talking manpower, and it was a pretty massive sort of a structure. It was there for 12 months or so while they punched this hole down to try and find the coal. And in 1908 Edgeworth David wrote a paper which referred to this drill hole and another one that he put in, and he showed it up Narrabeen Creek, over there about 500 metres or so on the other side. But the interesting thing about it is that they didn't get down as far as they coal. They got to a depth of 604 metres. They were well down into the Permian. They were probably within 100 metres or so of the coal measures, and at that point they gave up. They probably gave up simply because they'd run out of money, but it would have been shallow enough to actually start to mine coal in this location back in the early part of the 20th century if they'd found seams which were thick enough, and they probably are there. They did get gas. The gas was methane and nitrogen, and it was enough of it to use locally or domestically. Whether anybody actually did, I don't think so, but that was the story that they gave. And nobody recognised that it was actually gas coming from the coal seams, which was only 100 metres or so below the bottom of the drill hole at that stage. And of course coal seam gas is a big issue today because we're looking for it all over the Hunter Valley, all the way down through Camden and Wallandilly, and in various other parts of the Sydney Basin, and further up into the Liverpool Plains and the like, and it's become quite controversial because of the experiences that Americans have had seeking coal seam gas in their circumstances. Our coal seam gas story is not quite as bad as the Americans, but there's been so much antagonism towards it that the industry is currently being reviewed by state government, and it looks like it might be tightened up quite a bit. I've had some experience working with that one, and I've found that farmers are either for it or against it. They tend to be for it because it gives them good track access all around their farms. They can get new fences and so forth out of it, and they get paid royalties, and it's a minimum disruption to them. They're against it if they've watched too much American television and they appreciate what goes on with groundwater contamination and the like. But the problem is that most of the coal seam areas in New South Wales have absolutely awful groundwater anyway, which is not being used, and so if there is contamination, it's probably something of a non-issue. However, we don't know the details of these things, and I think it's wise that we slow down on the coal seam gas story. But here we have it, right underneath it. If you want to wake a hole down here, 600 metres, you can get it, and you can suck it out, and you can drive your local generator and power your house, etc. with it. There you go, 1885, and David and others are whacking a diamond drill hole down over there to find out what was beneath our feet, and that's how you assemble this geological column. David also in 1904 got interested in the question of how long has it been since this Narrabeen Lagoon has formed, and what was underneath it and what was it like. Here's a modern day image of the lagoon. You can work out where we are in the little clear patch on Deep Creek, and you can see that it's one big basin for accumulating sediment. there's an awful lot of sand and mud coming off these hill slopes and down all these creeks, Deep Creek, Middle Creek, etc., and pouring into the lagoon and slowly filling it up. You notice where the two creeks come in that there's a very different sort of a shape to the deltas of those creeks. Middle Creek, which is the one on the far side over there near the fitness camp, has a long thin silt jetty on either side of the stream channel. Silt jetties are formed by fine grained sediment, muds. Whereas this creek has a more lobate sort of a delta, just a generally rounded sort of blob of obviously sand. It's even vaguely yellowish on that particular image. That's just here. It starts at the bridge and runs out into the lagoon, and it's got a bit bigger over the years. Why would Deep Creek be carrying sand to the lagoon, but Middle Creek only carries mud? Middle Creek has a very wide valley. You drive all the way up it on the Wakehurst Parkway. It's a big, wide, flat valley, and it's full of sand. It's full of weeds too. That's about all you see as you drive through. But every now and then you get a bushfire through it, and then you see that the whole of the bed of that valley is covered in sand. So the sand that's coming off the sandstone slopes up in Middle Creek is being dumped higher up in the valley. Therefore, the only stuff that finds its way down to the lagoon is the fine-grained sediment that remains in suspension. It comes down as turbid, muddy flow during a high flow event. The water comes up in the lagoon, and as it spreads out across the shallow edges of the lagoon, it dumps a levee on either side of the channel, forming this silt jetty, a very prominent structure made of the fine-grained sediments, and the rest of it, of course, goes into the bed of the lagoon. This creek is much more direct. It just brings sand straight down the system and dumps it at the front, and that's it. The mud that comes down this creek, which would also occur, goes out into the lagoon and settles on the bottom. So the bottom of the lagoon is going to have a hell of a lot of mud in it and a relatively small amount of sand. How deep do you reckon it is? How much sand is out there? We're all guessing in the dark, aren't we? Well, David had his bore up here, and he had on that one, he had 27 metres to bedrock. And just above the bedrock, it wasn't sand, it was mud with estuarine shells. In his second auger hole, to 24 metres, he found mud underneath all the dune sands, and in that mud he found charcoal, casuarina cones and banksia cones. And he said, I'm again in estuarine mud, and he confirmed it a little bit further down with some more shells. So he had a depth of 24, 25, 27 metres, right across the whole of this lagoon flat we have estuarine muds. Now hang on, that water's practically at sea level. Plus or minus a metre, plus a metre say. That's not much. How can we have the estuarine mud down there at 27 metres and everything above that is recent marine shelly sand, blown in from off the beach or washed in from the thresholds from the entrance at Narrabeen? If the sea level was stationary, the lands had to sink. If the land was stationary, the sea level had to recede and come up. The Ice Age story had been around since the 1840s, but everybody had concentrated on the extent of glaciation and the effects of it, and they'd seen it all in the European Alps and they'd seen it again in Scotland. They recognised that there'd been huge ice caps across the Northern Hemisphere, but nobody ever put it together and said, where the hell did all the water come from? I'm not sure who first came up with the idea that, hey, sea level must have changed and we should find evidence of that, but it probably wasn't until the early 20th century, and David had been steeped in this other tectonic idea of lands going up and down all the time, explaining everything. So we've gone a long way, haven't we? From our bitumen asphalt through Hawksbury sandstone, through the coal seams down there, coal seam gas to global warming. 1943, Warringah Road has not yet fully gone through. It's being constructed at that time, and then there's this big complex of buildings literally just across the creek there. There was a fellow called Edward Giles Stone, and locally the place was known as the Never Been Beaten Lime and Cement Works. Whoa! It had a more formal name, which was Industries and Cements Limited, and he had a dredging licence for the lagoon to run from 20 years from 1933. And he constructed all this reinforced concrete stuff. He was going to dredge the sand out of the lagoon, screen it, and take the shell out of it, burn it for lime and make cement in his big plant over here. From 1943 to 1947 it produced very little. He did do the dredging operation, or some dredging operations, but he had a lot of fun building all these structures, plus a big dam up what is now known as Cement Creek. And why did it fail? Simply because there was only about 3% shell in the lagoon sands. You've got to dredge an awful lot of sand to get 3% of carbonate out of it in order to make cement and so forth. It just never could have gone. That wasn't the only attempt at dredging of the lagoon. They'd already had a go at it in 1911, and in 1950s and 60s there was a dredge down near the mouth, and in 1982 Warringah Council actually wanted to do it, and they did an EIS saying that they wanted to take 4.5 million tonnes of sand out over the next 20 odd years or so. Every now and then somebody sees this lagoon as being a huge resource of sand. Sand's a highly valuable product in Sydney for building and fill and so forth, and somebody says, oh, we got to dredge the lagoon and get it out. Well, we don't have any going on at the moment that I'm aware of, and we're not likely to have any in the next few years, but it is a big resource of sand, and some of it is quite reasonable quality except for that carbonate and the mud that's associated with it, but it can be cleaned. And the ultimate fate of Narrabeen Lagoon and all the other coastal lagoons is it will be filled with sediment and will be no longer a lagoon. Now that's a geological perspective again. Looking at it over the thousands, tens of thousands of years, millions of years, that lagoon is doomed to disappear. This is a typical bit of edge between the hill slope, colluvial sediments coming down there, and the alluvial sediments of the valley floor. And you'll see that you've got the big fallen blocks, or slid blocks really. They don't so much tumble out of those faces and come rushing down to the bottom here. They slowly get undercut and then slowly move their way down. So over thousands of years, that block there would have fitted back up the slope a bit, but probably not very far. And in fact, it's the slope that's going back, retreating into itself as time goes by. And you can see here the two different sorts of rocks that we commonly find in the Hawkesbury sandstone. The one in front of us has got lots of bedding structures through it. It's what we call the sheet Fassi sandstone, and the ones up on the slope up there, this little one over there in the above the biggest rock is more sheet Fassis, but the one below it is what we call massive Fassis. You can't see bedding planes through it. And it's the massive Fassi sandstones which tend to be the big trough cross sections of channels. These two things are deposited in different conditions in the original Hawkesbury River. The Hawkesbury Sandstone River had its headwaters in the Antarctic. Antarctic, of course, being joined to southern Australia at that time, 230 million years ago, or thereabouts. So the sand that came down it was well and truly matured, had been well rounded and polished and so forth by the time it got here. The river was only carrying sand, a bit of mud, and some of these little quartz pebbles up to about 2-3 centimetres, very occasionally larger. They're the bedload sediments, as we call it, and you'll find them in the bottom of these trough sections in the channels. The channels are filled with sand quickly in big flood events, and we say that was a high energy situation. The river's rushing through, carrying a lot of sediment, dumping it quickly, and thus not getting any bedding in it at all except the overall form of the channel. The sheet Fassi sandstone come as normal low flow conditions in lower energy, and these things are actually little dunes, sand dunes rolling along or creeping along the bed of the river over time. And so if you plot them out in plan form at any one level, you find they're twisting and turning and going in all sorts of different directions. You can actually work out the direction of flow from these features. And that low flow condition giving you the sheet Fassi stuff, high flow condition giving you the massive Fassi stuff. Composition is much the same in every case. It's all just quartz sand with a little bit of clay in amongst it, cementing it together. This is sheet Fassi sandstone. There's all our bedding, cross bedding sets there. Those are the bedding planes. This should be basically horizontal. This is a rock that has tumbled and rolled because it's now 90 degrees out of its natural position. But where is it? It's right on the edge of the alluvial flat. Probably the creek undercut in here, and it may have dropped this rock from just immediately behind it. So it hasn't tumbled down the hill, but rather just fallen into the creek. And that's as nice a section of Hawkesbury sandstone as you're likely to find anywhere. Plenty of sheet Fassis in there, but the top unit is almost massive. It's got a bit of bedding and cross bedding up there through it, but far end on the left it's tending to have nothing much at all, and the central one is pretty much the same as well. This is the sort of spot where you've got a bit of an overhang and a bit of protection, although it's a cold side of the valley, which is very likely to have Aboriginal occupation. It will be disturbed and buried now by the fill from the oval construction, but there's very likely to be Aboriginal midden material at the base of this section here. The vertical cracks are interesting too. These are joint blocks, these are joint planes, and the whole of the sandstone, in fact the whole of the Sydney Basin, is cracked up on a pattern which is roughly north, south and east, west. In places the joints are much more persistent, they run for longer distances, they extend to greater depth than in other parts. This is an area where it's not particularly prominent, but wherever it occurs you'll find that those joints are planes of weakness, and the creek lines tend to follow them. So the same north, south, east, west pattern is a pattern of stream tributaries. It's also the pattern of the coastal cliffs. It's not exactly north, south, east, west, and it varies from one part of the basin to the other, but the message is there that you have this cross-check pattern of the planes of weakness in these rocks, which are exploited by weathering and erosion and cause the landscape to actually have its own shape. The variation in colour in the sandstone towards the bottom here, we've got some quite orangey red brown. These are different concentrations of iron oxide in the sandstone, sometimes moving down through the rock, and under the bunch of fern over there in the middle of the section you'll find there's a lot of that brown sludgy staining. That's iron oxide being precipitated by bacteria, so there's actively iron oxides moving down through these things at any given time. And the sandstone itself is moderately porous, and of course that gives you staining in the weathered zone. People think there ought to be a lot of good groundwater in the Hawkesbury sandstone, but in fact there isn't, because the rock's tight enough to not have a great storage capacity. If you drill a hole through the sandstone you do get groundwater, it's reasonable quality, but the volumes are very small because it's confined to the vertical cracks, the joints and the open horizontal layers or beds as you go up through the sequence, and you can pump it out pretty quickly and that's the end of story. A rock shelter like this, as I commented, would almost certainly have Aboriginal occupation at the base of it, and very commonly had decoration along the walls as well, hand stencils and charcoal drawings and the like. Quite a nice flow in the creek. Another reason why Aboriginal people would have used this as a location for camping, because the main estuary could be a bit brackish and not such great quality. What's coming down that creek is, in addition to the water, is quite a lot of sand. A high flow, you can see it being dumped here in what we call a waterfall plunge pool, and at the bottom of it also we've got gravel, and the gravel is nearly all white quartz pebbles coming out of the Hawkesbury sandstone. The interesting thing about it is there's also quite a bit of blue metal, which is the black bits. So somewhere up there we've got urban development, and there's been blue metal washing down the stormwater drains into the creek and finding its way right down here into Deep Creek. Yeah, so you get this local contamination in the modern day pretty easily, pretty regularly. Why do we have an escarpment here with a waterfall on it? Remember, 27 metres of sediment just here. This valley was eroded out at the time of lower sea level 20,000 years ago, so that we had a very steep gradient from this creek all the way down to the valley floor, and it's had to cut waterfalls as it goes through to actually make the grade. Oh, a nice little sandstone cliff with a lot of mosses and lichens and stuff on it, and a bit more mesic vegetation because it's in that moist, sheltered side. And the bit that John's standing on, a little bit different. What's this one here? Concrete. With little round quartz pebbles in it. Obviously local aggregate, probably just simply dug out of the creek down there. Sand and quartz pebbles and a bit of cement. Here, sandstone, but it's a dressed block standing on end. Another one over here, and another slab of concrete just here. What's going on? A little building of some sort. Alright, can we find any more? Oh look, there's another lot. Dortmund. That's definitely Dortmund. Was it a man or a ship?
Ship.
Probably. I haven't checked that, but yeah. What have we got up here?
Eagle.
Yeah, German eagle. And down here we've got another flag of some sort. Whole lot of drawing-y feature things there, which I can't discern. More names. They're clearly not Aboriginal, and they're clearly old. And here's 26/11/87. I don't know. 87 is way back before the Gestapo.
Or after.
or after, but it's much older than if I'd carved it in 1987. A bit further round there's a swastika from memory, and there's more names and things up in there. Well, you hunt this out, and there was an article by John Morecambe in the Manly Daily a few years ago saying it was a German seaman's camp in between boats at the end of the 1930s. They came and camped up here while waiting for another ship to get out on. That makes some sense, but it isn't complete sense. Nowadays you can search all the references to these things in the newspapers etc. through the National Library's trove, and if you whack in Narrabeen Germans and see what you come up with, you come up with a couple of little short paragraphs in 1947 saying that in an isolated cottage in Deep Creek was the German Gestapo headquarters in Sydney, and in the 1930s it was regularly used for chastising seamen who didn't agree with Nazi principles, and they were brought up here, stripped to the waist and flogged. Now, I take that with a big grain of salt because I really don't think it happened, but that's the only trace you find of it in the Sydney Morning Herald, and it was in 1947, 10 years or so after the event, when I guess Australians were still pretty sensitive about what the Germans might or might not have done in Sydney. If you dig a little deeper, you find that in fact there was a cottage, inverted commas, or was it just a galvanised iron hut up here, and maybe that's the remains of it that we've just seen, which was owned or rented by the German embassy, and they regularly had picnics and weekend camps here at this point for Germans and Australians, both males and females, many of whom were seamen. And it was organised by a guy called Rudolf Durkop, who was alleged to be, and again I have to say the alleged to be the Sydney Nazi leader, and it was working for the Sydney Port Service. He obviously organised all these picnics over a period of about 4 years, from 1933-34, when the consul for Germany was in fact a Nazi and was very interested in what was going on in Australia from a military point of view, and this was an isolated spot where they did come for some sort of recreation. And then I found another reference to them which said that the worst thing that they did was that they sang German songs and they drank German beer. So there's a story here which nobody has got to the bottom of, but we clearly have some traces of, slapped on the Hawkesbury sandstone, with all of these rather elaborate carvings, and there's quite a lot when you get your eye in. They extend around this rock and around the next rock and further around. I think they had some sort of a galvanised iron hut or something that they possibly used as a kitchen, and they probably camped around the margins of the creek here and perhaps had canoes or something and swam in the stream, and it was nothing more, I suspect, than a weekend recreational place for seamen and whatever Australian girls they could find to come along with them. As for the guys being flogged, I doubt it.